big stuff. So here we go. Let's get through as much as we can. So yesterday, when I wasn't telling stories, I gave you a couple of formulas. Did you write those down? Yeah. And how do you decide which formula to use? Exactly. So if we are getting from term to term by multiplying by the same number, or if we're getting from term to term by adding. So here we are. We are ready for this problem. This is number 1B in section 9.4. Oh, by the way, I don't know if you noticed, there are a couple of 9.3 assignments. Did you notice that? Yeah. Okay, those are both due on Monday. All right, so you have the weekend. Some of you really turn one of them in. They're both due. All right, so tell what type of sequence it is, give a formula, and we're not going to do the cursive. We're not doing the cursive, so we're just going to give a formula. So what kind of sequence is this? What's happening? We're multiplying by -1/2, which means it's geometric and the ratio is -1/2. So our formula for geometric is this. And when you are writing your own, now this is the general geometric formula. This is for all geometric sequences. When you write one for a specific sequence, you just plug in whatever your first term is. This stands for first term. So your first term is -2. Then you put in your ratio, which is -1/2. And that's it. That's it. That's your formula. Now, please do not cancel these two negatives. I know you're used to doing that, but you can't cancel this one because it's hooked to this exponent. And will there be times when that won't even be negative? Yeah, if that's an even power, that negative isn't even there. So these cannot cancel. Don't do it. Just stop right there. That's it. Now, I stuck in down here at the bottom. We have an extra note. I'm on the right page. Yeah. The Fibonacci sequence down there at the bottom. This is the Fibonacci sequence. So write it down. And then we're going to talk about what's going on. I don't have that memorized. There's a pattern. Can you see the pattern? This is Fibonacci. Is it?
So 1 plus 1 is 2, and then 1 plus 2 is 3, and then 2 plus 3 is like just adding by the number in front of it.
Do you see what she's saying? So if you add 5 and 8, you get 13. And if you add 13 and 8, you get 21. So what will the next term be? Add 13 and 21, so that's what, 34? And then you add 21 and 34, and that is 55, and so on. Is this sequence arithmetic? I'm adding. Is it arithmetic? No, because to be arithmetic, you have to add the same number over and over and over again. And here we're adding different numbers. Is there clearly a pattern though? Yeah, Izzy found it. You all see it now, right? That's the pattern. The cool thing about Fibonacci, the sequence, is it actually occurs in nature. There are books written, I mean, like whole books written about the Fibonacci sequence, this pattern. Not necessarily the specific numbers, but the pattern. Next time you're out tromping around in the woods, pick up a pine cone. And if it's a pine cone that hasn't been damaged, you will see now they have those rings of kernels, you know, making the pine cone. If this ring has 8, the next ring will have 13, the next ring will have 21, and so on as you work your way down. Same thing in a sunflower. You know how all the seeds are in the middle, you know, the sunflower seeds in the middle of the sunflower? Those rings follow this pattern. A bee honeycomb follows this pattern. It's really fascinating. Do some research. It's very interesting. Now, can we write a formula like this for that sequence? Actually, we can't. We can write what's called a recursive formula, but I am like so out of time. I'm not going to do that unless I happen to have time at the end. So you cannot write an explicit formula for this sequence because it isn't arithmetic or geometric. And the terms of the sequence depend on the terms that came before. If I said to you, what is the 100th term of Fibonacci? Well, how do you find the 100th term? You add the 98 to 99? Well, shoot, where did they come from? You added the 96 to the 97th, right? You see the problem? The problem is there's no shortcut for this guy. You have to go term by term. Can't do an explicit formula for him. All right, but you can with letter C. C you can. It's a harder one. But I want you to look carefully at these numbers. Now, don't look at what you're adding or multiplying by to get from term to term. Look at the numbers themselves. Look at the numbers themselves.
It's adding every odd number.
Okay, so you are looking at what we're adding. So she says, get from here to here, I added 5, and then I added 7, and then I added 9, and so on. Writing an explicit formula for that's going to be hard because you're not adding the same thing. You're adding different things. That's what's happening. Again, kind of try to put that out of your mind. Add 1 to all these numbers. Every single one of these numbers, just mentally add 1 to them. What do you notice when you add 1 to all those numbers? What do you get? You get 1, 4, 9, 16, 25, 36, 49, 64. What do you get? You get the squares. You get the squares. So these numbers are the squares minus 1. That's your explicit formula. If you want the 5th term, 1, 2, 3, 4, 5, the 5th term will be 5 squared minus 1. It sure is, 24. So again, the pattern Kelsey noticed is awesome. She could keep her sequence going. But in terms of writing a formula, that's going to be kind of tough to do. This is easy. They're the squares, less 1. Tricky, tricky. Don't stew about it too much. It's a little tricky. All right, from the first 3 terms and the 50th term. First 3 terms. And the 50th term. All right. Anybody have any idea? This is more sequence notation and sequence type problem. Remember, when I say A sub 50, that means the 50th term. So I want the first term and the second term and the third term and the 50th term for these 2 sequences. All right, so let's look at the first one. Any ideas how we might do this? Lillian?
I have no idea.
No idea?
No.
Okay, I want you to look at this. And then the problem is A sub 1.
You plug in the 1 for the end.
Yes! That's all you do. So you plug in 1 for the n. So isn't that going to give me 1 plus 1 over 1?
Yeah.
So 2?
Yeah.
All right, so what am I going to do for this one? Plug in the 2. So that's going to be 3 halves. 3 over 2. And then I'll plug in 3. Get 4 thirds. And then they skip a bunch and we go to the 50th term. Well, I do the same thing. The 50th term will be 51 over 50. Easy. Okay, what about this next one? What's the first term of this next sequence? Nope, it's not 4. What is it? First term. 4 over 3. Perfect. And the next one will be 1, because it's 4 over 4. The next one, 4/5. And the 50th one, 4 over 52, which actually reduces to 1/13. Both of these sequences have something in common. And we're going to talk about it for a minute because it's going to help us with our next set of problems. If we kept going, I don't know if you noticed this or not, but even with just the first 3, are these terms staying the same? No. Are they getting bigger or are they getting littler? They're getting smaller, right? Well, what if I did the 100th term? That would be 101 over 100. Are they all getting smaller? Are they still getting smaller as we go? They are, aren't they? Are they just going to get, are they like heading towards something? They're getting smaller, but are they just going to keep like getting smaller all the way to Loretta Hall? Or is there like a wall they're not going to go past? They're getting smaller and smaller and smaller. But is it like to infinity smaller? Or is there something that will stop them? What do you think?
Is there one that would make it 0?
What?
Is there one that would make it 0?
Well, that's a good question. Will this ever be 0? No. Think about it. This says that the top number, whatever the top number is, it's always going to be 1 more than the bottom number, right? So if the top number is 1 more than the bottom number, so we would end up with things like 1,001 over 1,000. Will that ever equal 1? Will this fraction ever equal 1? No. It'll always be slightly bigger than 1. Would you agree with that? But the farther down the line I go, the closer I get to 1. Like if you type this in and got a decimal on your calculator, it'd be 1.001. But if you did this, it would be 1.001. The limit of this sequence, what we call the limit, as n approaches infinity of this sequence is 1. It's getting smaller. But if I'm 1 on the number line, if I'm the number 1, here comes the sequence. It's getting smaller and smaller and closer and closer. And it keeps getting closer to me, but it will never pass me because it's going to stay bigger than 1. You've already done this. You may not make the connection yet, but you've already done this. Remember when we were graphing things like y equals x over x plus, or x plus 1 over x? Do you remember when we were graphing those things? We were putting in asymptotes and holes and all that stuff? That was my horizontal asymptote. That's the limit of the sequence. So when we talk about what's the limit of the sequence, it's exactly what the horizontal asymptote was. So the limit of this sequence is 1, n over n. Now what about this one? What's happening to these numbers? Well, they're getting smaller, right? Where would the asymptote be if the problem were 4 over x plus 2? Where would your horizontal asymptote be? You guys must have a horrible teacher. How do we find a horizontal asymptote? We compare the x's. How many x's do you have on top? Remember, 0 over 1. What's 0 over 1? 0. So the limit of this sequence, the limit as n gets bigger, approaches infinity, of 4 over n plus 2 is 0. You find the limit, and that's what the next question's all about. You find the limit the same way you find the horizontal asymptote. So let's skip the first two because they're set up a little bit differently. How about C? What do you think the limit of C is? 3. I'm looking at C. 3n over 1n. Would you agree? Now, convergent means it has a limit. Do you remember there are some problems that have no limit? Remember we had no horizontal asymptote sometimes? That's called divergent. That's divergent. If they have a limit, they're called convergent. And in this case, number C, it converges and its limit is 3. What about D? -2. The limit is -2. Perfect. -2. It converges. You have -2n over n. What about E? It's the limit of E. I heard somebody say it. Would you say, Ollie? 4/5. What do we compare, you guys? What do we always compare? The highest power, the biggest power. So we have 4n squared over 5n squared. And that is 4/5. Very good. How about F? 0. F is the same as this one. F has no n squared over 1n squared, and that's 0. So the limit in F is 0. Now, before we go to the next page, which has some more, I want to go back and get A and B. What do you think the limit of A is? Think about those numbers. As you keep squaring them, 1 squared, 2 squared, 3 squared, 4 squared, 18 squared, 97 squared, what's happening to those numbers? So 97 squared, then 98 squared, then 99 squared. I'm on problem A. I'm squaring. They're getting bigger. Is there a wall they're going to hit, or are they just going to keep getting bigger? They just keep getting bigger. Divergent. A is what we call divergent. It has no limit. The terms just keep growing. Off they go. They just keep growing. What about B? 3B. Think about those terms. What do you think is happening there? They're getting smaller and smaller. Now, are they going to get smaller and smaller all the way? Like when I think of smaller, here's my number line. Are they going to keep getting smaller all the way down here? Now wait, in letter B, will they ever be negative? Can 2 to the nth be negative? No. So they're never going to be, they're going to get smaller, but they're never going to be negative. So what's their limit? 0. The limit is 0. So A has no limit, B is 0, and C, D, E, and F we already did. All right, how about G? Yep, Donovan?
Why can't B be negative?
You can't raise 2 to a power and make it negative, right? 2 to a power means 2 times itself, and since it's positive, that answer will never be negative. Does that make sense to you? All right. G. What about G? No limit or divergent. No limit, divergent. Why? Somebody besides Julianne explain to me how we can look at problem G and know it has no limit. Abby?
Because you look at the biggest power and with the 2, so it would be like 8 over nothing.
Exactly. It is 8n squared over 0n squared. Can you have 8 over 0? No. And if you can't have it, then you can't have a limit. So there's no limit. It's called divergent. That's the math word for that. Now, I'd like you to look at H and I. They look very, very similar. Now, they are different. They are not n's over n's. They're not this kind of problem. They're not n's over n's. There's something raised to a power. H and I behave very differently. Can anybody tell me about the difference in that behavior? And if you can't, then get your calculator out and start typing in 2/3, the fraction 2/3 to higher and higher powers. When you find a limit, it means you're letting n be bigger and bigger. So type in 2/3 to the 8, and then type in 2/3 to the 18, and then type in 2/3 to the 100. Just keep typing in 2/3 to bigger and bigger powers, and tell me what happens. What's happening? What's happening? Getting smaller. Think about it, kids. If you keep multiplying by 2/3, isn't your number getting smaller? Isn't that making a smaller number? Will it ever be negative, though? No. So what's its limit? 0. When you raise a number less than 1 to a power, the limit's going to be 0 every time. Every time. When you raise a number less than 1 to a power, the limit will be 0. It's going to get smaller every single time.
When it's 0, is it convergent or divergent?
No, if it has a limit, it's convergent.
Okay.
So the only ones that you'll say divergent for are the ones that have no limit. So like they're undefined or something, okay? If it's 0, it's definitely convergent because that's the limit. The limit is 0. So if I change this to a 2/5, the limit is still 0. Okay? If I change it to a negative 2/5, the limit is still 0. All right. Now, what about I? Multiplying by more and more 2/3 made our answer smaller. Well, what happens when we multiply by more and more 3/2? It gets bigger. And in fact, isn't it going to keep getting bigger? I mean, as we just keep multiplying by 3/2, isn't it just going to keep growing? So what is the answer to I? Divergent. There is no limit. It's divergent. How about J? We shouldn't have to think about this. Is 5/4 bigger than 1 or less than 1? Okay, what happens when you raise a number bigger than 1 to a power? Diverges. Yeah. So J is divergent. Now some of you are thinking, but wait, this is for the exponent's different. No one cares. If you're raising a number to a power, the only thing that matters is the size of that number. The exponent doesn't matter, the coefficient doesn't matter, it's the number you're raising to the power. So tell me about K. 0. 0.36 is less than 1. So the limit's going to be 0. How about L? Divergent. 1.5 is bigger than 1. Those are easy peasy, right? All right, number 4. Okay, so wait, so that's the end of the limit discussion. So we looked at 2 kinds of problems, 2 different kinds of problems. One were our old problems, where we had n's over n's, and we said we're going to find the limit that way by comparing the highest power, right? And then the other kind is this new situation where we have a number raised to a power, and all we do is look at this number right here and decide if it's bigger than 1 or less than 1. Bigger than 1, divergent, less than 1, 0. Every time. Got it? Okay. Number 4, find the first 5 terms. Find the first 5 terms. Well, this is easy. I'm kind of erasing it already. We did it a minute ago. Find the first 5 terms of the sequence. Well, you're looking at that and thinking, no, Mrs. Ford, that looks very different. I'm not sure what's going on here. Looks a mite scary. Don't be scared. Remember the problem I just erased? We had n plus 1 over n. And we had to find a sub 1. So what did you do? You plugged in 1 for all the n's, and you figured it out. So this problem says we need to find the first 5 terms. So we need to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Now, the good news is, I already know the first term is 3. They told me that. It's part of the problem. So now I gotta find the second term. Well, let's look up here in our formula, right here. If we want to find a sub 2, then don't we need n to be 1? If we let n be 1, won't that be a sub 2 then? So I'm going to let n be 1, and my formula says a sub 2 equals 2a sub 1 minus 5. I let n be 1, so then my formula says a sub 2 equals 2a sub 1 minus 5. Okay? But what's a sub 1? 3? So don't I have 2 times 3 minus 5? Would everybody agree with that? It says take 2 times your first term and subtract 5. So I got 1. Any ideas about how to find the next term? Let n be 2, because if you let n be 2, what will your formula say? If you put a 2 in for the n's, what does it say? A sub 3 equals 2a sub 2 minus 5? Well, what's a sub 2? 1. So this is 2 times 1 minus 5, or negative 3. Now what do you think I'm going to do? What do you think I'm going to do now? I'm going to let n be 3. Because if I let n be 3, my formula says a sub 4 equals 2a sub 3 minus 5. But I know already that a sub 3 is negative 3. So I got negative 11. Now, will you find the last one for me? I can't tell if your brains are working or if you're just staring at me.
-27.
You haven't got -27? I haven't done it yet, so I don't know. Did anybody else get negative? Oh, we got some thumbs up back there. Way to go, Gavin. What did you do? You let n be 4?
5.
Yeah. So you had 2a sub 4 minus 5. So 2 times -11 minus 5 is -27. Beautifully done. Beautifully done. Now we're only going to do one more of these, so we'll do the next one. So this one, my formula says a sub n plus 2 equals a sub n plus 1 times a sub n. And I am finding a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. This is my job. Find the first 5 terms. Now, what's the good news? They gave me the first one and the second one. Gave them to me. So the first one I have to find is the third one. I need a sub 3. So what am I going to let n be? 1. So if I let n be 1, my formula literally says, put a 1 right here for the n's. It says a sub 3 equals a sub 2 times a sub 1. Let n be 1. And that's what it says. But I know that's 3 and 4, right? So what's a sub 3? A sub 3 is 12. Okay, now what? You're going to find some more. How am I going to find a sub 4? Oh, those are n's, remember? How am I going to find a sub 4? Maybe 2. So a sub 4 will equal a sub 3 times a sub 2. You get 48. All right, go ahead and find the last one for me. Let n be 3. Let n be 3. So it says a sub 5. That's what you're looking for, a sub 5. It's a big number. I mean, relatively speaking. Did you get a sub 4 times a sub 3? I got 576. Anybody else get 576? Basically, what's going on here is the Fibonacci idea, but you're not adding, you're multiplying. So multiply these two to get the next one. Multiply these two to get the next one. Multiply these two to get the next one. Right? We got a little bit more to go. I know it's been a long day. Lots going on. We've got to get some math done. Consider the sequence. find the common difference or the common ratio, find the 8th term, and an explicit rule for the nth term. Do not be confused by the vocabulary, that just means find the formula for the nth term. What's going on here in this sequence? What kind of sequence is this? I heard somebody say something about -4. So we keep adding -4. So what kind of sequence is it if we're adding -4? Arithmetic, right? So look back. What is your arithmetic formula? A sub n equals a sub 1 plus d n minus 1. I will give you the formulas. You do not have to memorize them because we're going to be getting some more. But you have to know which is which. This is the arithmetic formula. So we want the 8th term. Well, according to our formula, a sub 8 equals what? What does a sub 1 stand for? First term, which is 3. What does D stand for? The common difference, which is the number that you keep adding. So that number is -4, -4. And then n minus 1. Now keep in mind, you're finding a sub 8. So what's n minus 1? 8 minus 1, or 7. So the 8th term looks like it's -25, if I did my arithmetic right. First term plus the common ratio, or common difference, the common difference times n minus 1. Now they want you to write a formula for that. Easy. Plug in your first term, which is 3. Plug in your common difference, which is -4. Clean it up, and that's your answer. When you write the formula, all you plug in is the first term and the common difference. Then I can distribute. So my formula is 7 minus 4n. Now let's see if you can do the same thing with the next one. So we want to find a sub 8 again, and then we want to find a formula for this particular sequence. Okay? So what do you notice about this sequence? You're timesing by 2. So if you're multiplying by 2, it is not arithmetic. If you're multiplying by 2, it is geometric. And your formula for geometric is this one. That's the formula. So if we want the 8th term, a sub 8, we'll take our first term, which is 3. We'll multiply it times the ratio, which you said was 2. And then what power am I going to raise it to? If I'm finding a sub 8, I'm going to raise it to what power? I'm doing a sub 8. I'm raising it to the 7th power. N is 8. So my exponent is 7. So 3 times 2 to the 7th. Please do not combine the 3 and the 2. The answer is 384. Do not combine the 3 and the 2. We talked about this way back in chapter 1. They have to stay separate. for our explicit formula, easy, easy, easy. Plug in the first term, which is 3. Plug in the common ratio, which is 2. That's what we multiply by. And your exponent's n minus 1. When you build your own formula, all you plug in is the first term and the common ratio, or the first term and the common difference, depending on what kind of sequence you have. This does not simplify. You are done. Will you try C on your own? See if you can find the 8th term and a formula for the sequence. Is he working on this? Good. Anybody have an answer yet for the 8th term, Ollie?
Negative 13,122.
You are so close. I think it's positive. And the reason it's positive, Ollie, it could be the way you typed it in.
I forgot to add a sign to my
It's negative 6 times negative 3 to the 7th.
I forgot to add my sign within the 3.
Okay, yeah. And that is, shoot, 13,122, was that it? Did everybody recognize that's geometric? Did everybody recognize your ratio is negative 3? So it's first term times ratio to the 7th. That's going to come out to be a positive number. I hope that your formula just looked like this, because that's all it has to look like. That's it. Your first term's negative 6, your ratio is negative 3. How many got 13,122? Okay, you're awesome. Let's try D. Do the same thing. Find the 8th term, and then the formula for the sequence. I got 6.5. You get 6.5. This one's arithmetic, so I use that formula up there. Girls. Now, for my formula then, I plugged in my first term and my common difference. And then I distributed and simplified, and I got this for my formula. Does that look like what you got? Always?
Do you want a fraction or
Doesn't matter, it could be a decimal. Whatever you want. this one you can collect like terms. You can't with the geometric. Alright, let's skip that last one because it's exactly the same kind of thing, and we're gonna do numbers part 6. Then I'll shut up for the day. Kylie?
And there's division, that's geometric.
Well, it's multiplying, yes. Geometric means you multiply by the same number, right? So,
Number, this letter E, I looked at it and I got, you guys can divide.
so multiply by 1/8. You multiply by 1/8. When you're doing arithmetic or geometric, you must either add or multiply. There's no subtraction and there's no division. So if it's subtraction, you're going to add a negative, and if it's division, you're going to multiply by the reciprocal. Okay? Every time. All right. Now, what makes 6 interesting is, look at that first one. Remember, guys, if we can get through this, I'll be done. You can stop. We gotta get through this. So it says the 4th term is -8, and the 7th term is 4. And we know it's arithmetic. So they tell us it's arithmetic. So if I do a picture of it, here's my first term, second term, third term. My 4th term is -8. My 5th and my 6th and my 7th term is 4. That's what the sequence looks like. I just don't have a bunch of the numbers in it. And they want me to find this right here, the first term. They help me to figure out what that is. Now, this can be very logical for those of you that are logically minded. This can be very logical. Ollie?
Let's see,
Negative what?
-20, right?
Okay, he says -20. Now, Ollie, how did you do that? Where did that -20 come
So,
from?
since it's
Arithmetic, uh-huh.
right? So the way that you got the -8 forward, that you would plus 4 to get to that forward.
Okay, now wait a second. So let's listen to what Ollie's saying. He's saying that to get from here to here, we added 4. Now, Ollie, how did you know that?
Because you just have to do the arithmetic way, you just have to do it by the sequence of doing the same thing over and over.
Okay, Ollie's just thinking, right? He's just thinking. And that's really good. He's not using any formulas. He's not using anything except his own common sense. I think what he's trying to say is, I know that to get from here to here, I have to add the same number 1, 2, 3 times. And the difference from here to here is 12. So if I have to add the same number 3 times, and it adds up to 12, then doesn't that number have to be 4? And that's wonderful. But Ollie needs to go this way. So if he was adding 4 to go this direction, he will do what? Subtract 4 to go this direction. There's a formula way to do this problem, but it is awesome that Ollie is just thinking about it because it's way faster just to think about it. Did anybody have a different goal? You actually could think about this a different way. Did anybody think about it a slightly different way? How about, when I wrote it down, it occurred to me, how many gaps are there between this number and this number? There are 2. I want this number. How many gaps are there between the number I have here and the number I want? 2? So doesn't it make sense that if this distance is 12, doesn't it make sense that this distance would also have to be 12? but in the opposite direction. So negative 8 back up, 12 would be negative 20. Let's look at the next one and see if we can figure out what's going on there. Don't know what the first term is, but the third term is 3. Or the second term, I mean, is 3. Don't know what the third, fourth, fifth, sixth, seventh is, but the 8th is 192. And this one is geometric. Ethan.
It's multiplying by 2.
Right, Ethan says it's multiplying by 2. Now, you know I'm going to ask you how you know that, but let's just see if you're right. That would make this 6, 12, 24, 48, 96, 192. You're exactly right. We're timesing by 2. But now, Ethan, where did you pull that out of what hat? How did you know that we're timesing by 2?
I just, I did it by, I noticed, it was a lot of spaces, but it didn't go up, a lot. So first I just tried multiplying it by 3, then it was too much, and then I went to 2, and then I got it right.
I love it. So we've got Ollie's strategy, which is, I'm just going to sit here and think about this for a while. We got Ethan's strategy, which is trial and error. He looked at it and said, okay, it's not going up a huge amount, so I think I'm going to multiply by a low number, like 3. That turned out to be too big, so then we tried 2. Anybody have oh, by the way, then what would the first term be? If we are indeed multiplying by 2, then what would this first term back here be? 1.5, 3 halves, or 1.5? Well, it's geometric, right? So that means we're multiplying by something. What does it take to get from 3 to 192? What do I have to multiply by? What's 192 divided by 3? 64? So somehow I have to multiply by 64 to get from here to there. Would you agree? Now, I have to do 1, 2, 3, 4, 5, 6 separate multiplications to get to that end number. You see what I'm saying? I have to do times, 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 times. So something multiplied 6 times gives me 64? Well, you can exclude that on your calculator, and that's 2. Or you can remember that 2 to the 6 is 64. Or you can do what Ethan did and trial and error. Now I'm going to throw a little kink in here. What if, instead of timesing by 2, I multiplied by negative 2? If I multiplied by negative 2, I get negative 6, positive 12, negative 24, positive 48, negative 96. Uh-oh, would negative 2 work? Yeah. In which case, what would this be? If I'm multiplying by negative 2, then this number would be a negative 1.5?
So is it just plus and minus?
That's right, there's actually 2 answers to that problem. Because I could have a ratio of 2 or a ratio of negative 2. I love it. You're thinking today. Very good. Some of you are thinking anyhow. That's wonderful, wonderful, wonderful. Let's think about this one. We have negative 5. What is that? A sub 9. That's 5th, 6th, 7th, 8th. 9th term is negative 17. I don't know what these are. That's the 5th term, 6th, 7th, 8th, and 9th term. And C is arithmetic. Abby. She says she's subtracting 3. So minus 3, minus 3, minus 3. Now, Abby, what what was your thought process? And again, you're right, it works, you're right. What was your thought process?
It was arithmetic, so I knew what it was at multiplication, and then I just tried -3 and ended up working the first guy.
She and Ethan, trial and error, it's awesome. Trial and error is perfectly legit, feel free to do it. Sometimes it takes a long time, that's a little bit of a drawback, but it's perfectly okay. Myself, again, as I'm writing out the problem, I'm thinking, okay, they told me it's arithmetic. So I have to add something 1, 2, 3, 4 times. Would you agree? So to get from -5 to -17, which is a distance of -12, I have to add the same number 4 times. So doesn't it make sense that number would be -3? So go backwards. If I'm minusing 3 going that way, I'm going to be adding 3 going this way. So -2, 1, 4. I got 7 for my first term. Is that what you got? You guys are brilliant. One more and then I'll shut up. Third term is -75. Fourth, fifth, and the sixth. Oh, that's good. I don't think this one's going to be a plus or minus because I'm multiplying, right? It's geometric. And if I multiplied by a negative, this term would be positive, this one would be negative, and that one would have to be positive. So I am not multiplying by a negative, I am multiplying by a positive number. Has anybody figured out what that positive number is? Well, let's think about it. How many times do I have to multiply by it? Once, twice, 3 times? So something to the third power has to get me from -75 to -9375. So divide. 9375 divided by 75 is 125. So something multiplied 3 times to get from here to here to here has to make the jump of 125. 5 to what power? Oh, should I give it away? 5 to the third is 125. So I am multiplying by 5. Try it on your calculator. -75 times 5 is -375. Times another 5 is -1875. Times another 5 is right there. So how am I going to go backwards? Divide by 5. So -75 divided by 5. Divided by 5. Your first term is -3. Does anything we just talked about is sort of gelling in your head? Because if that makes sense to you, that's how I want you to do the problem. I don't want you to do a bunch of formula work. Sometimes we have to do formulas.